Okay, so lastly is calorimeter. So calorimeter, there's a few equation that you need to know lah. So we've been talking about enthalpies. So what does enthalpies in terms of calculation? So it is Q over N. Alright, so where Q is the heat, right? Okay, and N is the moles lah. Okay, so based on this, okay, moles we know how to cari, so we need to know how to cari Q lah. So Q is equivalent to C delta T, okay, where C is heat capacity. Okay, so kalau they just give you heat capacity, so that you can use terus lah. But what if the equation, the soalan give you specific heat capacity? So this is heat capacity, and we know that heat capacity is equivalent to M kecil c. So what is M kecil c? Right? M kecil c is specific heat capacity. Specific heat, H-E-A-T capacity, and M is mass. Okay, it's just a measure how well the substance to conduct heat lah. Okay, and delta T is T final minus T initial. Okay, so hence why we get the Q is equivalent to MC delta T. Alright, mass times specific heat capacity times the T final minus T initial. Alright, so we have two types of calorimeter. We have bomb calorimeter and we have simple cup calorimeter. The equation will let you know if it used bomb calorimeter or simple calorimeter, because there's two types of things and we can tengok lah. So for bomb calorimeter, right? So bomb calorimeter, so kita akan tengok the heat release. So Q reaction. Okay, so Q reaction is equivalent to the negative, okay, kurungan M calorimeter C calorimeter delta T. Okay, and also tambah dengan M water, H2O, and C H2O delta T. Okay, let's figure out kenapa dia negative. Negative, the reason why it is negative, it is the heat release lah. Okay, M is the mass of calorimeter times specific heat of calorimeter times the heat, the temperature change, and this is the mass of water times the specific heat of for water and the temperature change. So the specific heat of water is always the same, it is a constant, is 4.1, so 4.18. Okay, sometimes for bomb calorimeter dia tak bagi langsung mass water. Okay, so for that, for kalau soalan tak bagi langsung mass water, you just should you should assume that the soalan already dah campurkan the heat absorption of water with calorimeter. So in this case, in that case lah, heat of reaction is equivalent to the negative of M calorimeter times specific heat of calorimeter times delta T. That's it. Okay, tapi kalau dia bagi mass of water, you have to use this one lah. Kalau tak, you can use this one. Alright, so simple cup calorimeter. Okay, kita guna macam styrofoam. So in this case, the QRXN, which is reaction punya heat, is equivalent to the negative times mass of water and then calorimeter, specific heat for water and delta T. Kenapa saya tak masukkan for calorimeter? So usually for soalan simple cup calorimeter, the mass of calorimeter and specific heat of calorimeter times delta T, okay, which is the heat for calorimeter, the heat absorbed by the calorimeter is not considered lah. Okay, selalu kita akan hanya guna up to this point. Okay, and just one thing for simple cup calorimeter, the reaction that usually kita akan buat is neutralization. Okay. And soalan usually dia tanya delta H. Okay, so delta H, what you need to know is delta H is equivalent to Q over N. Correct? So you need to know the N. Okay, apa mole yang you perlu guna? Because kalau neutralization, we have two lah. We have acid plus base become salt and water, H2O. Okay, so apa moles yang kita perlu guna is kita perlu guna the moles of water. We need to know this moles. Okay, tapi kita nak tahu mole ini dari mana? Is obviously daripada acid and base. Okay, for neutralization we always use mv over 1000. Okay, N is equal to mv over 1000. Okay, find the limiting, find the excess. Okay, because we know that limiting is the one yang akan contribute to the product punya moles. So daripada limiting reactant, you know dia punya moles, you can find Q, you find dari atas, you should be able to find the enthalpies of neutralization lah for simple cup. So that is for calorimeter.